that gives you an idea how these muscles are going to provide movement for the body. So I like this because it's giving us an idea already what we're going to be seeing now on the muscles. Let's see the video. See what
The interactions of the 9 muscles that cross the glenohumeral joint are complex, and each muscle contributes to more than one movement. Additionally, movement at the glenohumeral joint can take place in all directions, where associated muscles can act as synergists in one type of movement, and then antagonists in another type of movement. Therefore, 6 movements of the joint and humerus will be considered: flexion, extension, abduction, adduction, medial rotation, and lateral rotation.
So that's it. All right, so you have those introduction of the muscles. We're going to start looking at some of these more and more. All right, so let's go ahead and begin with chapter 6. Remember, with chapter 6, this is the only chapter you have for essays. Right? So we began by determining right here what's a long bone. Remember, you need to basically have an idea for this lab test also. It deals with exercise number 8. You had a question like that. Place the in the table which are the ones that were long bone, short bone, irregular bone. So again, go back to that review question of exercise number 8 of your lab. Coincides with this chapter 6. So you need to know which ones are irregular bones, flat bones, or short bones, and so forth. So the long bone, we did a big deal because those are the ones that have these 3 areas: diaphysis, metaphysis, and epiphysis. Well, we put them correctly. Again, the epiphysis is the top area. Metaphysis is the borderline between the epiphysis and diaphysis. Diaphysis is the shaft. Once again, the epiphysis is spongy bone at both ends. So you need to know the difference. What is the bone composition at the epiphysis? And the answer is?
Spongy bone.
Or calcaneous bone. Spongy or calcaneous bone. That's the answer. Again, with chapter 6, you got to know that. This was also with exercise number 8. You're going to see this on your lab test. Okay? Epiphysis, metaphysis, diaphysis. You got to know that. Okay? So the epiphysis is calcaneous bone or spongy bone. Remember that this area receives the stress first, and then it sends it down through the spongy bone, through the lining of the medulla. When it gets to the diaphysis, that compact bone basically is not receiving the stress. It's the marrow cavity that is receiving it. Remember that long bones do have marrow, but as you pass adolescence, then you have yellow marrow. In the cranium, the example of these flat bones of the cranial bones, we don't have a marrow cavity. It's called this, diploid. Diploid. Okay? That's what you have. So repeat that. What it says here, flat bones of the skull have a marrow cavity that is known as diploid. You gotta know that. That's for lecture. Okay, remember, we see here relevance of exercise 8 that you did for lab kind of coincides with this chapter. Pretty good. All right, moving on. Okay, so remember, we have compact bone and spongy bone. What's the difference? It's more porous, and compact bone is more dense or solid. Yeah, tight sheets. Because both of them have sheets. You got to know the name of those sheets. These are the lamellae. Okay? So lamellae is, the lamellar sheets are basically in both of them, but it is the depositing of these sheets that is either going to be a spongy, calcaneous, so less compact than the compact bone. And remember that we have blood vessels in the central canals. passing through all these central canals. So there's a whole bunch of central canals. So when we look at this slide right here, we see here the first essay. What are the two main components of bone? And what's the relationship? So it is organic collagen, inorganic calcium phosphate. What's the relationship?
The collagen is deposited in the collagen? Or is it the collagen is deposited in the
Yeah,
collagen?
no. You deposit the calcium onto the collagen. Yes, you need the collagen so that you could deposit the calcium onto it. Yes. So that's the relationship. So you need the collagen, the fibers first, and then you can deposit the calcium onto it to make bone. Did you get that? All right, any questions for the first essay? All right, so remember we have osteoblast. What do these do? Make bone. Osteoclast? Break down. What do the osteocytes do? Maintain the bone. That's right. Maintain the bone. Lamellar, again, the lamellar bone is basically, these are the sheets that either you're going to make the calcaneus or the compact, lamellar. So remember that right here, this is also referring back to exercise 8. What happened when you cook the bone? What did we remove when you cook it? That's why you're going to be like that.
Collagen.
The collagen leaving behind the calcium phosphate, the salt. So that's what becomes brittle. So people that have problems with collagen, making collagen, they're going to get a disease. Remember, that's in your lab. The lab was saying about rickets. Brittle bones, rickets. So that was a fill in the blank that you had there. So that's what happens when you cook the bone, similar to rickets. You destroy the collagen. What about when you put it in acid? You only remove the calcium. The bone becomes bendable. Okay, so put it in acid, you remove the calcium and the phosphate, and you only leave behind the collagen, it becomes bendable. You gotta know that. Okay, so again, bones in acid, you remove the collagen, it becomes bendable. I'm sorry, the crystal becomes bendable. Remove the salt. Any questions on these figures right here, these two pictures? When you cook it, it's the top. When you put it in acid, it becomes bendable. You gotta know why. No collagen, the one on top. This one, no calcium. All right, so with that, we saw the osteoclast. Remember, these guys are destroying bone. And they do that through the release of hydrogen ions. Basically, it's acid. Acidity is destroying the calcium and taking it out from the collagen. All right, so here is basically where we see that the lamellar sheets, these sheets that make up the bone, can make this circle. These circles right here, we call them concentric lamellae. And when you have them completely mature, the whole thing becomes an osteum. So that means that you cannot get any bigger because the distance from the central canal to the edge is too far to bring nutrients. That's why there's a limit. So the central canal, remember, is where you have the blood vessels. So the circle, the size of the circle, how many circles you get depends on how far can you transport those nutrients. So that's why when it stops developing the circles, the osteum, that's what you get. You get an osteum. And the osteum is composed of concentric lamellae. And you have these circles, these osteums separated from each other with interstitial lamellae. And then you have another sheet, lamellar sheet, that wraps this whole thing. See that? That's what you see in compact bone. What about spongy? We have lamellae sheets here, see that? But they're not really condensed. They basically branch out. So that's why the lamellae here make up trabeculae. These little branching structures. The spongy bone. All right? So the trabeculae is the spongy. Compact bone has the concentric lamellae or circumferential lamella. See that? And remember that the blood vessels could cut across the bone. That's Buchman's canals. Again, this is what the structure of the bone, how you have the lamellae making them. The perforating canals, the Buchman canals. These are the canals right there. Let's not forget that. Perforating canals. Okay, so that's an important point. This is referring to the blood vessels going across. They're not just going up and down. All right. So that brings us up to the reading that you have to go ahead and do from the textbook. This is dealing with the two ways that bone is produced. So bone can be made from membrane that acidifies. That's what this is telling us. Intravenous acidification. Or it could be from cartilage that it acidifies. So you need to read up on that one. The two basic ways to make bone. How does bone come about? So in other words, bone doesn't just start off with bone. It's either a membrane or cartilage. That's why there's a very pricey dish, and it's with a fetal calf, and it's very delicious apparently. But it's because it's all very soft. That's why it has to be a fetal. It's very, very expensive. I don't know if you've heard about that. But anyways, so that's with the ossification not fully developed. So remember, the fetus, a human fetus, also has cartilage and also that will acidify, and membrane that will acidify. So you got to read up on that one. Okay. So from this part, we went ahead and talked about. Again, this is all part of the reading. You can read up on that. We're skipping it. Okay. We talked about the again the stress lines, how the stress from the bone, any stress or weight passing through the bone, it is actually affecting the spongy bone, not the compact bone. The spongy bone has higher ability to resist stress. Compact bone cannot resist the stress. So that is why these lines, stress lines, are demonstrating to us where that stress is going. It's being channeled through the spongy bone and through the inner medullary cavity. See that? Through the spongy bone there. The trabeculae that you have here. Okay. So that's how stress is being passed down. And remember that it's important that you remodel the bones. How are you going to remodel your bones? How do we do the remodeling of bones? Stressing them, right. Yes, exercise, especially impacting. I haven't showed you the most widely approved exercise. Okay, and it's not weightlifting. All right, this was done also by the astronauts. That's how this guy came about. This is from the 1979. The guy developed it. It went big in the 1990s in Asia. Let me show you the technique. All right. That's it. But in a trampoline. Yeah. You know why? It has nothing to do with it, but it's kind of, I thought it was interesting. When you're working out in the gym, what cells are you working out if you're just doing this? Just the ones in your arm. See that? When you're doing your legs, you're only doing your legs cells. Or your back. But what about a sport, or in this case an exercise that impacts the entire body? That's what this does. Not only does it give you the gravitational force when it's coming down, but also when it's going up. So you're affecting a multi-axis. So that's the interesting thing. The guy actually, remember, this was actually analyzed, and the astronauts, that's their exercise. And this is actually something to tone your body, but you have to be jumping up and down the trampoline. But that's to give you the impact. So that's what you need to do. And it helps you for any exercise, no matter what age you are. That exercise is for you. And it also activates your entire body cells. So not only is the ones in your arms, your head, you see everything is being impacted. It's doubling up their action. So if you want more about that, you can look it up. Okay. This is do the trampoline exercise. Anyways, so that is an exercise that everybody should be doing. That's the exercise for you. It's not going to the gym. All right? Because it doesn't work. Remember, you have to be fully dedicated. All right? Anyways, but that's the one you got to know. All right, what about calcium regulation? You got to know this one. That's your second essay. When calcium is low, what happens? Tell me. When calcium is low. When calcium, you got to say it like that. When calcium is low.
The parathyroid releases the parathyroid gland.
Yes. Yes. The parathyroid gland will secrete, remember it's in the back of the thyroid, will secrete parathyroid hormone, PTH. PTH will go into the bloodstream and cause what? And the small intestine. Remember, it will activate the kidney and small intestine to absorb calcium and phosphorus because it's low, below normal. What about the bone? PTH goes to the bone.
Directly activates the osteoclast.
It activates the osteoclast with a C to
break down the bone to release calcium and phosphorus.
That's right. At the same time, what else is released by the kidney? Let's not forget that. We jumped the gun on that. Why? The kidney also releases what? The PTH will also cause the kidney to secrete calcitriol. Remember, it will affect the kidney and small intestine to absorb calcium and phosphorus. Don't forget that one. It will also affect the kidney to release calcitriol. Anyways, what about when calcium is high? Calcium is high. Again, the C cell, when you gotta say that, when calcium is high, the C cells in the thyroid gland. Remember, when calcium is high is a point. That's why you're saying. There's calcitonin, and then calcitonin is gonna
To the blood?
yeah, it goes into the blood, and it's gonna cause the kidney and the small intestine to
Not to absorb.
not to absorb. No. Right, not to absorb. Calcium and phosphate. It goes to the bone. Tell me about this one. This one, calcitonin goes to the bone. What happens? Indirectly, it will affect the osteoclast by blocking PTH. And as a result, the osteoblasts will deposit the calcium onto the bone. Remember, calcitonin goes to the bone and indirectly it will block PTH from activating the osteoclast. This will allow the osteoblast to deposit calcium into the bone.
Is this one for essay 2 or part of the essay?
Yeah. Now all that is your essay. It's 5 points, 5 points, 10. See, 5, 5. Okay? And the last thing that we had is what fracture did you gotta know? That's it. All right, so we'll start next time on chapter 7. Remember that this Friday we have our test. The math practice. Please do not be absent. Make arrangements if you're going to be absent. Does anybody need to take it like on Wednesdays? I gotta know. Thanks for making me work. No, okay. No, she's going to take it. If anybody else, what we're going to be doing is after the break right now, we could go ahead and do that. Yeah. Can you do that at 12? After this class? Yeah. All right, so again, if you're not going to be on Friday, please make arrangements. All right, we'll see you on Wednesday. We're reviewing on chapter 7 now. Remember, chapter 7 is going to be on the exoskeleton and the appendicular, the specific points from that. Once again.